Today we're going to talk about electric circuits. Before watching this video, make sure you understand what an electric current is and the difference between a conductor and an insulator. Now that you know that, we're going to be able to talk about electric circuits. An electric circuit is a complete path through which a charge can flow. A complete path means that it's following in a circle, right around, from a battery to some sort of resistor, which normally is a light bulb, sometimes to a switch, and back to the battery again. There is no spot along the way where this circle is broken. If the circle is broken, if it doesn't connect all the way through, we have, instead of a circuit, we have what's called an open circuit. We're going to get more to that later in this video. Current flows from the positive to the negative, and electrons flow from the negative to the positive. So this blue circuit that I've drawn, is the arrows are showing the direction of electron flow. This green circuit, or circle, the arrows going the opposite direction from the positive to the negative, this is our direction of current. Make sure you have in your notes that electrons move one way and current flows the other. You're going to have to be able to label these on a worksheet or on a quiz. There's two types of circuits. There's series and there's parallel. Let's start by talking about series. Series has only one path. That one path is ridiculously important. It has only one path through which electricity flows. If one element doesn't work along the way, the entire element doesn't work. Think about Christmas tree lights. You know when all of a sudden they all stop working? It normally means that one bulb has gone out. And your Christmas tree lights are in series. Just like this picture here. See how they're all connected in one path? There's no way for electricity to go the other way. We can use the analogy of a road. Think about one-way streets, a city block. There was a car accident right here, and it stopped traffic, and you wanted to go maybe here. You currently were here in your car, such a nice car, and you're traveling this way. There would be absolutely no way for you to get here because the accident has the road closed, and there's no way around it. You can't get to where you want to go. See, that's what happens in a series circuit. If one light bulb goes out, there's no other route for the electricity to have to get back to the battery. The second type of circuit is a parallel circuit. This is where there's at least two or more paths through which the electricity can flow. If one element doesn't work along the way, doesn't mean that the whole thing isn't going to work. So if this light bulb all of a sudden stopped working, the electricity still could take this path here, right around, back to the battery, and this light bulb would still light up. Let's use the same street analogy here. If you wanted to get to, say, right here, and you're currently here on your drive, there was a car accident right here. This is your normal route. You go from here down to your school or the pizza shop or wherever you're going. This is your normal route. And there was an accident here. You now can't take that route. So we would have to have a backup plan, another route to go. But we would be able to, instead of going that way, come down and along the outside to where you want to go. Just because one route is blocked doesn't mean you can't complete the loop. So we're going to have to be able to draw these. These are called circuit diagrams. Okay, they use symbols to represent a part of a circuit. There's open circuit and closed circuit. An open circuit has something like a switch. And that switch is open. The lights are turned off. This is exactly how the switches in your wall work. When you turn the light off, it picks up this little piece of metal that makes the circuit be incomplete. This is like there being an accident on the street. You can't get around it. You can't jump that gap. So the electricity doesn't run, so the light doesn't work. Closed circuit is a complete loop. This is a symbol for a switch here. See how the switch is across all the way? So right now, I can trace this path of this line all the way down to a light bulb, through the switch, and back to the battery without picking up my pen. So this is an example of a closed circuit. This will light, or they'll have the radio turn on, or whatever this resistor here is. In order to draw these circuit diagrams, we need to use different symbols. And please watch the second video on the symbols of a circuit diagram in order to be able to practice drawing these circuit diagrams.